As we continue our discussion on the graphs of trig functions, we're going to move into the translations of sine and cosine. Previously, we've talked about just the basic graph of the sine and cosine function, along with the idea that it's a wave pattern. It has a period and an amplitude, and we saw the 5 key points also, which are also going to be key in this discussion. Now we're going to talk about the translations, which really what we're meaning there are the vertical and horizontal shifts of the graphs. Okay, but before we get into that discussion, there's an algebra topic that I want to review. It's kind of a review, but it's also a little bit new. I'm going to put a little different spin on it than anything you may have seen in a prior algebra course. Mainly we're going to be talking about factoring. And you guys probably, I'm sure you've seen this before, factoring out a greatest common factor from a pair of terms or from a binomial. You know, something basic like 2x plus 6. If I were to factor 2x plus 6, the two terms share a common factor of 2. And so I can pull the 2 out, and I'd be left with x plus 3, okay? Now, this factoring idea is actually going to be important when we get into translating, because we're going to have to do some factoring to figure out when we get there, it would be what the horizontal shift is, or the phase shift of the graph, okay? But for right now, I just want you guys to focus on the skill of factoring. Now, this was kind of a basic one. And they get a little bit more complicated because we're going to see some things that aren't quite as obvious that there's a common factor involved. Give you an example, something like 1/2 x plus pi over 2. And you might say, well, it's not really clear that there's a common factor on this one, but there is. There's a common factor of 1/2. Fractions can be common factors, and so you could actually pull that out. You could pull out the 1/2, and you would have x plus pi left over as your two remaining factors, or remaining terms. Remember, when factoring, you could always redistribute to check your answer. As in the first example, if you redistributed 2 times x, you get 2x, and 2 times 3, you get 6, okay? So you would get 2x plus 6 when you redistribute. Here, 1/2 times x is half x, 1/2 times pi is pi over 2. And so if I redistribute the half, I end up with the original expression. So what I want you to know, you probably haven't seen factoring fractions, okay? That's what I'm assuming, because it's not often taught in an algebra course. Maybe some of you have seen this before, or maybe it's familiar. But we can even make it a bit more tricky by pulling out things that aren't clearly in both terms. Give you an example, something like 1/2 x plus 5. Now, there's no visible factor in common. The 5 has factors of 1 and 5. 1/2 x has factors of 1/2 and x. And so none of those are common. However, 5 could be written as 1/2 times something. What is 1/2, or what is 5 equal to? 1/2 times 10, right? 1/2 of 10 is 5. And so in some sense, this 5 really does have a factor of 1/2 because it's 1/2 times 10. So if you were to factor out or pull out a factor of 1/2, you would be left with an x and a 10, okay? In other words, the remaining factors are the two things that you would have to multiply by a half to get the two original terms, right? So what do you multiply by a half to get 1/2 x? Well, just the x. What do you multiply by a half to get 5? Well, the answer is 10, right? So if I redistribute, 1/2 times x is 1/2 x, 1/2 times 10 is 5. It does work out, okay? So we can actually factor out things that are not clearly common factors, because in some sense, when we deal with fractions, we can pretty much make anything a common factor, okay? We can even make really weird things like square roots and pi and other things common factors. Let me give you an example. You could do something like pi x minus 2 pi, okay? Now this one's not quite, this one is a little bit more obvious because there's a pi in both of them. But we could pull out a pi and we'd be left with the x and the minus 2 as my two factors. Again, if you think about redistributing pi times x and pi times 2, you get the two original terms. But when we get into these fractions, going back to the fractions now, you know, when you factor out a whole number, you're dividing the terms by the whole number, like the 6 divided by 2 gives you the 3. But here, when you factor out the fraction, it's almost like you're multiplying by its reciprocal, right? So like 5 times 2 would give you the 10, okay? So just like here, dividing by 2 is like multiplying by a half. So you're essentially multiplying by the reciprocal to get what's left. So I'll give you another example. If I had 2/3 x plus, let's go with 8, and I wanted to factor out, it's going to be common for us to try and factor out whatever the coefficient of x is. And so here, if I pull out the 2/3, then what I really need to do is multiply the 8 by the reciprocal, which is 3/2. Okay, and that would give me the remaining term. So if you think about what is 8 times 3/2, well, 8 over 1 times 3/2, the 8 and the 2 reduce to 4 and 1, and you end up with a 12. So you get 8 plus, or x plus 12. Now think about redistributing this. 2/3 times x is 2/3 x, and 2/3 times 12, well, 2 times 12 is 24, divided by 3 is 8, okay? So it does work out. And so the technique we're going to use then to factor out a fraction is to multiply the remaining number by its reciprocal to get the new term, okay? Again, this is not something that I would expect you guys to have seen already. It's kind of a tricky idea, but it is useful. It does actually show up when we do this translating stuff. So I do want you to be familiar with it. I'll give you one more quick example here, trying to give you a variety of things that you could see when working through the homework or on a test. I'll try one that's a little bit harder. Maybe something like pi over 4x minus 1/2. This one's a little bit tricky. So here, if I wanted to factor out and get just an x by itself for the first term, I'd have to factor out pi over 4. So I factor out the pi over 4. That leaves me with the x in the first term. Now, well, obviously there's going to be a minus. Now the 1/2, remember what I have to do is multiply by the reciprocal of pi over 4, which is 4 over pi. So if I think about 1/2 times 4 over pi, well, the 4 and the 2 will reduce, and I'd be left with 2 over pi as my second term, okay? And again, you could mentally or actually redistribute to check your work, right? Pi over 4 times x is pi over 4x, and pi over 4 times 2 over pi, well, the pi's would cancel. The 2 over 4 is 1/2, and that's what we had before. No pi's and a 1/2, okay? So, factoring out really anything at the end of the day can be done as long as you remember that you multiply by the reciprocal to get your final two terms, okay? Again, we're gonna see this show up a few times as we do our translating, so I want you to be familiar with these kind of quirky factoring ideas.